What's up, guys? Today, we're gonna compute the derivative of arctan of x. Before that, let's go over an important theorem, the Pythagorean theorem. So, assume you have a right triangle. Let's call A and B the name of the size of the triangle that is not the hypotenuse. The hypotenuse is the side in front of the right triangle. Right triangle means one of the sides is 90 degrees. Okay, so the theorem says a squared plus b squared is going to be equal to the hypotenuse squared. Let's call the hypotenuse here c. So a squared plus b squared is going to be equal to c squared. But right now I want to think this triangle is inside a unit circle. It means the radius is 1 and my hypotenuse here is going to be my radius. It means 1. So let's replace c by 1. Okay, so if I call this angle here y, what would be sine of y? Yeah, it's opposite over hypotenuse. Opposite side over hypotenuse. Opposite is a. Hypotenuse 1, so it's just a. What would be the cosine of y? Adjacent side over hypotenuse. Adjacent is b. Hypotenuse 1, so just b. Replace sine of y and cosine of y in your Pythagorean equation. We're gonna have sine square of y plus cosine square of y equals to 1. Let's assume the cosine of y is not 0. We're gonna work in some intervals that's not 0. And then we can divide both sides of our equation by cosine square of y. And then we're gonna have sine square of y over cosine square of y plus cosine square of y over cosine square of y equals to 1 over cosine square of y. Okay, sine square of y over cosine square of y is tangent square of y. Cosine square over cosine square is 1. 1 over cosine square of y is secant square of y. Let's call this blue star, and we're gonna use very soon. Another thing, the derivative of the tangent, I'm assuming you guys already know, but I'm going over very quickly. The derivative of tangent of y, tangent is sine over cosine, so we can use the quotient rule, simplify, and use the property that we have mentioned before. We're gonna have the derivative of tangent as secant square of y. Okay, great. So what is arctan? We know arctan is the inverse function of tangent. Let's call here y. Okay, great. The inverse function of tangent of x is equals to y. Apply both sides the tangent. So when I apply my function in my inverse function, I just get the real value. In that case, x. X is equal to the tangent of y. So here, if you apply the implicit differentiation both sides here, I'm going to apply the derivative. I'm going to have implicit function because tangent of y depends on x. We're going to have, what is the derivative of x? Yeah, 1. What is the derivative of tangent of y? Is y prime, is the derivative of y, times the derivative of tangent. Oh, we know that, and we call double yellow star. That is definitely secant square of y. Okay, let's divide both sides by secant square of y. So y prime, the derivative of y, is 1 over secant square of y. Let's use the equation blue star and replace here. And then we're gonna have the derivative of y is equal to 1 over 1 plus tangent square of y and then I replace, because I know the tangent of y is x, so it's 1 over 1 plus x squared. Okay, that's perfect, because what is y? Y is the arctan. And then we're finding the derivative of arctan. I hope you guys enjoyed the video. Give a like, make comments, and see you in the next video. Bye bye.